Hey guys, so let's start with communications and internet. So this is part one of the lecture series where I'll be introducing the topic and discussing network topologies. So I'll be covering the information that's required to give the A-level exams, and for understanding the concepts, I'll try to cut down on as much unnecessary information as I can. But it's always good to research on your own, so I'll probably encourage you to do that. But I'll still be covering all the topics you'll need to get that A star. So, the first thing that should come into our mind when we think about networking is data transmission. There are five requirements for data transmission. The first one is having a sender, the second is having a receiver, the third, the message that you want to send over, and the fourth, a transmission medium. The fifth and also very important one is having a protocol set to transfer this data. First, let's look at some networking topologies. The first one is peer to peer. It is the simplest possible network topology in which n systems are connected by a network link. The peer to peer network makes use of the Bit Torrent protocol for sharing files. There are three things the Bit Torrent protocol runs on. The first is a tracker. It is the central server that stores details of other computers that have all or part of a file to be downloaded. It has data on peers downloading and uploading the file. It shares the IP address with other clients in a swarm, allowing them to connect. So, what is a swarm? A swarm is all the connected peer computers that have all or part of the file to be downloaded. And they're essentially just machines that share the torrent. So we have one more definition we need to go through, which is the definition for seed. It is a peer computer that has 100% of a file and it uploads the downloaded content. Let's just look at another explanation, alright? So here we would have our tracker, which is the central server which is going to manage all the IP addresses and where the files go, right? And let's just draw a lot of N systems. These are all computers, right? Now, one of these computers is going to be a seed because you have to have 100% of the file to transfer the whole data. So, for example, if this is the seed, which means it has 100% of the file. Now, all of these are peers, right? This is a peer. This is also a peer. Now, all of the peers and the seeds together, they form the swarm. And this altogether forms is basically what the BitTorrent protocol works on. Alright, now let's look into how the BitTorrent protocol works in a little more detail. So first, the BitTorrent client software is made available. Then, one of the computers must keep a complete copy of the torrent file to be shared, which is the seed. The torrent file is then split into smaller pieces. A computer joins a swarm by using the BitTorrent software to load a torrent descriptor file. A computer can now download a piece of the file. Once a computer has a piece, it can become a seed and can upload to other members of the swarm. Pieces of torrents are both downloaded and uploaded by each member of the swarm. A server called a tracker keeps record of all the computers in the swarm and parts of the file they have. It is possible to pause and restart the transmission at any time. So that was basically it for peer to peer. Now let's look at bus topology. In a bus topology, we have one link that is shared by multiple end systems, and only one transmission is possible at any given time. All the nodes in bus topology can read the data that is being transmitted, and the server can read all of the incoming packets from the internet. Collisions are possible in bus topology, and only one transmission is allowed on the bus at any time. Therefore, if two packets use the same bus at the same time, the attempts to transmit will fail because the stations will realize that the bus is busy and a collision can cause a change in the voltage of the bus. To attempt successful transmission again, the system will first calculate a random wait time. It will then wait for this random wait time, check the bus status, and then attempt retransmission. There are some benefits to the bus topology. The first benefit is that it's easy to set up. It is also so that it requires less cable because the central line is the same. However, there's a lot of disadvantages to the bus topology, and let's list them down. The first one is that if the main cable breaks, the network performance is badly degraded, which effectively means it won't function at all. Second, it is difficult to detect and troubleshoot faults at individual stations. Third is that its efficiency reduces as the number of stations increases. So we'll say efficiency reduces as nodes increase. There's also a possibility of collisions occurring, and the security for such a topology is definitely lower than what we would want. Several computers will receive the same signal sent from the source. Right, now let's look at star topology and why it is obviously an upgrade over both peer-to-peer and bus topology, and it does not have collisions as in bus topology because every end system has its own dedicated channel, its own dedicated network link. So in star topology, we must have a central device, which is the switch over here, and each node is connected to the central device. Each node has a dedicated connection, and each connection must be bilateral, as shown with the two-way arrows. Nodes may operate under different protocol. There are multiple transmissions possible at a single point of time, and collisions are not an issue here because of the use of a switch, a central device. Packets sent cannot be read by other devices, so that is another advantage that comes up to privacy and security reason. Security issues are widely reduced here. The benefits are that the signals only go to the destination. It's easy to connect and remove nodes or troubleshoot devices. The centralized management helps monitoring the network. Failure of one node doesn't affect the rest of the network, and performance doesn't degrade under load. Connection may use different protocols, and there are fewer collisions. The drawbacks are that if the central device fails, then the whole network goes down. The performance is dependent completely on the capacity of the central device, the switch in this case. Note that even though collisions are not possible when a star topology is created, a switch has a number of ports, each that connects to a single device using a dedicated cable. The switch provides a transmission path from the device to the other device, and collisions are no longer possible as there are dedicated links from computers to the server. There are some more concepts we need to look at. The first is the number of data flow methods. There are three data flow modes. The first is simplex. In simplex, the flow of data is only one way. In half duplex, the flow of data is both ways, but it's not simultaneous. Data is not sent and received at the same time. And in full duplex, the flow is both ways and the data is sent simultaneously. We then need to know the types of messages and what they mean. There are three message types. The first is broadcast. In broadcast, the message is sent from one to all. So from one device to all the other devices. The second is multicast, where the message is sent from one to many. So not all of them, but many of the devices. We then have unicast, where the message is sent between two devices, so it's one to one. Let's now look at a few more other important terms. First, we have a server. So, a server is a computer hardware or a software that provides functionality to other devices, other clients connected to it. A server also has a few more functions. It provides a firewall and checks all the internet traffic. The server can also act as a proxy, which is an intermediate between a client requesting a resource and the server providing it. This diagram shows the connection between a client, a server which acts as a proxy, and the internet, the server that is providing the resources. As you can see, the connection between the client and the server, the internet in this case, is not the internet server is not direct, but it's through another server which is called the proxy server. You see, when you order a pizza, you supposedly get 8 slices of the whole pizza, right? But when you order data or you ask for data to be transmitted over, it does not work in the same way. Data is first split into different packets, and these packets are then individually sent from one device to another, or transmitted from routers to other routers, or so on. So you basically have each slice of pizza delivered separately to you consecutively, each in different boxes and each with your address on it. Now, each of these slices is called a packet, and every packet has these five things stored into it. It has the message itself, or the payload, in this case the pizza. It has the sender's IP address, so the address of the pizza delivery, the pizza place where they make the pizzas. It has your address on it, which is the receiver's IP address, and the packet sequence number. So you receive pizzas all in an order: the first slice first, the second, third, fourth, fifth, sixth, seventh, and eighth. And then you have a checksum. This ensures the integrity of the data, that it does not have any errors while transmission. If, for example, this is our data and this is our checksum, then the sum of data, which is in this case 1 plus 3, will be equal to the checksum, which is 7. This ensures that the data, based on the sum, has not undergone we don't have any data loss or errors or so. Now let's talk about routers, this device at your home that you keep switching on and off when your internet does not work. So the main purpose of a router is to establish communication between computer networks. So a router transmits packets. It contains connections to many other routers, and when packets arrive at a router, the router decides where next to send that packet. One thing you're really frequently asked is to define a router, and maybe they just give it for 2 marks or they don't expect a very long answer. A very important point that you have to mention over here is that a router bridges two different networks. For example, it could be a LAN and an internet connection. Routers can also be used as gateways and firewalls. Although they are essentially different, but since gateways connect two dissimilar systems and routers have the same ability to do so, They can also act as gateways. As a router forwards packets between different networks, it may operate on two different protocols as well. A router has its own public IP address and holds a list of local addresses. The router translates the local addresses to IP addresses and vice versa. Now it stores all of this information in a routing table. A routing table stores the network ID or the subnet mask. It stores the routing metric, which is used to decide the best possible route for data to be transmitted over, and the IP address of the next hop. It also includes and stores the interface. A subnet mask is used by a computer to determine if an other computer or the target is on the same network or a different network. If you wish to learn more about this, I have added a link to a description to an amazing video about it, and I suggest you go there. Interface is basically when you log into your router, put your IP address in the web browser, and you get the web interface. That is what the interface means. Now we will be looking at the working of a router. First, in the transmission of packets from the router itself to a web server, and then in an email from one email server to another. Let's put this down here. Right. So there are a few steps here which you might benefit from remembering. So first, the packet has the IP address of the web server or the destination address. The router then forwards the packets to the destination. The routers use routing tables, allowing the packets to take different routes from the source to the destination. The packets are then reassembled in order at the web server. The next scenario we look at is a router sending an email from one email server to another. So first, the email is split up into packets, and each of these packets has a destination address. Packets pass through many different routes in their journey, and they don't all take the same route either. And the router uses the IP addresses to reassemble the packets at the destination to rebuild the final email. Alright, guys, so we have one last device, which is the network interface card. Network interface card. Now, this gives every device a unique MAC address so it can be identified in the network. This is also extremely a very crucial part of a computer, a network computer, because this network interface card allows it to connect to the network. So this is it for the first part. I have uploaded the entire notes, which are quite beautifully made. I've made them myself, and they're there in the description. Please do take a look at them, and I think it'll really help you. See you in the next part.